Life happens in real time, and so does data. Consider for a moment this scenario. Ordering a rideshare, then monitoring the progress as the car makes its way to your curb. You know to the minute when to step outside. We all take this and experiences just like it for granted. Experiences enabled by a storm of data, processed and then presented, all in real time. It hasn't always been this way. In fact, even today, most data is collected, stored in centralized databases, and then batch processed on the hour, day, or week. But imagine how some businesses could be transformed with real-time processing of live data streams, or what we call data in motion. Finding patterns and responding to significant events as soon as they occur can allow banks to create personalized solutions that help customers meet their financial goals, sound the alarm on cyber threats before they become massive data breaches, alert supply chain managers of unanticipated stock depletion, accelerate clinical trials, bringing critical medicines to market faster. There is no limit to the application possibilities, and it's not as hard as you think to transform from batch processing to real-time data in motion. Let Confluent show you how.
Real-time data beats slow data. This is true for any software application, including AI and machine learning, where you do predictions, recommendations, or alerts. This is Kai Werner with Confluent, and in this video I will explore how data streaming with Apache Flink will help to do real-time AI and machine learning model inference. Before we talk about real-time AI, we need to explain what data streaming with Apache Flink means. Apache Flink is a stream processing framework. This means you can continuously process incoming events, transform them, aggregate them, correlate them, and combine them. Or you can use stream processing also for real-time model inference. This is the main topic of this video here today, where we will learn how you can leverage data streaming for real-time model inference, both for predictive analytics and AI, and also for generative AI with large language models. Let's now dig deeper into the specific topic of model inference with Flink. Flink itself is an application as part of the data streaming platform. To use stream processing with Flink, you need data inputs from different data sources. This can be then used for any kind of integration or business logic. But in our case, we want to combine it with AI. And in this example, like in most cases, the analytic models are deployed in its own model server. In this case now, we get input data from machines, payments, mobile apps, or whatever. And then we use the data after we pre-process it and send it into the model server. Then we do our prediction or generation and get the result back. This can be done via API calls, synchronously, asynchronously, or maybe more in a streaming mode. You have many options here. But the main point is the stream processing and the AI infrastructure are decoupled from each other. With this, you can scale and operate them by themselves. For example, in the model server, you can do A/B testing, versioning, and so on of your models, and still use all of that together with your real-time stream processing application. And then you use the result from the model server as part of your real-time stream process. So here now, where we get input, process it, use it for real-time model inference, and then we use that prediction or generation of a model to use it in the next part of the business process. Typically, this goes into another Kafka topic, and from there into many other downstream applications. The next Flink application, a third-party data lake, or maybe just a BI tool for batch reporting. So that's now the big picture, how you can do model inference with Apache Flink. And for the model perspective, you can use any third-party AI ML application or infrastructure, like OpenAI or Anthropic, or you build your own custom models for your risk and fraud prevention within your entities. You have the freedom of choice and can leverage all of that as part of your real-time stream processing application, no matter if they're analytical or operational. With data streaming and Flink, you can do both. Now let's speak a little bit more about the implementation and architecture of such an environment where you want to do real-time model inference with Apache Flink. The foundation of all of that is an event-driven architecture. With this, you have truly decoupled applications that can use their own technologies and communication paradigms, but then still you can send it to the streaming platform for continuous processing and model inference. The core of the data streaming platform is Apache Kafka. This is where you get all your data sources into, no matter if it's real events coming from some message queue or other interface, or from a database, or from some logs or sensors. So as a first part of Apache Kafka, we stream data in real time at any scale. And then as a second step, we add the stream processor, Apache Flink. So Flink, together with Apache Kafka, is the foundation of the data streaming platform. The processing part with Flink can be used not just for the model inference for AI use cases, but also for the pre-processing, for the aggregations, for all the use cases where you need to process data. And you can choose between Flink SQL or between the table API and leverage programming languages, including Java and Python. So some interface for almost everyone. Let's now discuss why Apache Flink is so great for AI infrastructures where you can leverage it for real-time model inference, like in this picture here. First of all, Flink provides low latency. So you can process even huge volumes of data in real time if you need to. And this really means at gigabyte scale per second. The combination of low latency and scalability is very powerful. But what's also very important is robustness. In contrary to some batch and reporting workloads, the data streaming platform runs 24/7 and it's elastic at scale so that you can really use it for your most critical and operational workloads and for analytics. And obviously, with that, in the end, as data streaming platform unifies the traditional data workloads and the AI workloads. You still have the freedom of choice of your AI technologies, but you can combine them together and build one scalable real-time data infrastructure with the streaming platform. So now, when we talk about a data streaming platform, I already covered the two key open source frameworks, Kafka and Flink. But a data streaming platform is much more than just gluing together some open source frameworks and operating and scaling them by yourself. A complete data streaming platform provides all of that together in a complete solution. And this means on the one side, the stream part we already covered with Kafka. And then we also have the process part with Flink. In addition to that, we also need to do data integration to data sources and data sinks. That is typically Kafka Connect. Kafka Connect can be used for any kind of interface. Traditional databases, IoT interfaces, cloud lakehouses, AI platforms, anything you need to connect to. No matter if the interface is a real-time or a database or an API. You get all of that as an event into the event-driven architecture to then continuously process it with Flink afterwards for ETL or for AI model inference in real time. And we don't need just to do stream, process, and connect everything. We also need to govern the entire pipeline. Data governance means things like data lineage for visibility across the entire pipeline. We need it for good data quality, but also for security and compliance reasons like access control, audit logs, encryption or attribute level. A data portal then for self-service where you can access the right data you have access to process it by yourself in your business unit. And all of this together in a cloud-native, elastic way with consumption-based pricing and still where you needed mission-critical SLAs. This is really what a complete data streaming platform means, and Kafka and Flink are the core of that. Now with the understanding of both how model inference with real-time streaming works and how an event-driven architecture looks like with a data streaming platform. Now let's explore a few AI use cases and how data streaming helps. First, you can do predictive analytics and AI with data streaming. Predictive AI means you do real-time model inference for use cases like fraud prevention, predictive maintenance, or customer recommendations. This is where you often have trained your own custom model based on your business data and apply the model inference to do the right outputs and predictions within your business process. This can be innovative new use cases you couldn't build before, or this could be extending your existing business processes. So such a business process maybe exists before, but with real-time model inference as part of the streaming platform, you can improve the quality of the decisioning. You can also do generative AI use cases, leveraging large language models with the data streaming platform. Generative AI typically uses large language models, and they are typically not built by yourself because it's too hard and expensive. So typically you use something like OpenAI, Anthropic, or any other large language model and leverage that as part of your architecture. Data streaming with an event-driven architecture can be a great foundation for combining your existing data sets with the large language model so that you can implement design patterns like RAG, Retrieval Augmented Generation, which means that you can provide the right semantic search on top of your existing third-party large language model to make the right decisions and recommendations and generate data for your topics, for your business. And at its core, I said this in the beginning of the video, real-time data beats slow data. And no matter if you use predictive AI or generative AI, think about that. You always need the data up to date. Otherwise, AI is hallucinating. It's sending wrong recommendations or alerts. And this is where data streaming is much, much better than batch and data lake technologies, where the information about predictions often comes too late. And also not in a consistent way, like in a streaming platform. And this is really the real value that a data streaming platform brings, to combine it with any kind of AI or machine learning application or infrastructure. So we learned how data streaming powered by Flink can be used for real-time model inference, especially relevant for operational and transactional use cases, which should never be done in a data lake or lakehouse. But in addition to doing the model inference, obviously the data streaming platform is the core of most AI infrastructures. So you combine data streaming with your favorite data warehouse, data lake, or lakehouse. The lakehouse is the best technology to train models, to do analytics and reporting, batch processing, and so on. But to get good quality in here, you can use the data streaming platform to pre-process the data. Shift some of the processing to the left side, closer to where the source is, where it's created. And with this, you can make the data better quality, reduce the cost, and still get all the relevant data into your favorite lakehouse to do the AI model training there. And then for the model inference, you can choose per use case. For critical use cases, for low latency, for robustness, you do that with Flink and its model inference capabilities as part of the platform. Or you also use it in the lakehouse in some scenarios. You always have the freedom of choice with a data streaming platform, what technologies to choose as a data source or as a data sink. To conclude this video, let me walk you through a concrete example now. Let's talk about manufacturing and predictive maintenance. This is a very interesting scenario because it is a hybrid scenario. Manufacturing is always at the edge. It's at a shop floor where you produce tangible things. And from there, then, like in this example, you see some sensors here, equipment. You feed this data directly in real time into the data streaming platform. In many cases, it's Confluent Cloud, the fully managed service. And from here, then you can pre-process and aggregate the data, like in this example, sensor data for temperature, for pressure. And the aggregated data is then fed into an analytic model so that you can detect anomalies continuously in real time. In most cases, it just goes through and runs 24/7. But in the case of an anomaly and alert, an alert is sent to a mechanic. And this mechanic then in the shop floor level stops the machine before it breaks. Because again, real-time data beats slow data, and finding out that a machine broke after the fact in the data lake analytics, that's too late. With data streaming, you can do all of that with real-time model inference now, when it matters most, before something happens. And this is not just true like in this example for predictive maintenance, but relevant for any industry. Think about fraud prevention, recommendations, rewards, alerting, You name the use case in your industry. And data streaming can help with that together with your favorite AI platforms. I hope this video helped you understanding how data streaming with Kafka and Flink is connected to the AI and machine learning world and how it helps with real-time model inference. As part of a complete data streaming platform like Confluent Cloud, you can get this out of the box built in. You don't need to code this by yourself. You can just do real-time model inference as part of the streaming platform and connect to your favorite AI models like OpenAI and Anthropic. Feel free to share any kind of feedback and questions directly to me, reach out on LinkedIn, or comment on the video to get feedback or questions. Thanks a lot for watching. This is Kai Werner with Confluent.
Notion is a collaborative workspace for documents, wikis, project management, and more. It's also your AI Everything app, which provides a powerful AI toolset. We have two main Gen AI use cases at Notion. We like to call it the find and the do. We have the ability to find content and use retrieval augmented generation to be able to answer people's questions based upon the content inside their own workspace. And the other is we like to be able to generate new content, new pages based upon all of the stuff that exists in their workspace, or sometimes also what comes out of LLMs themselves. We're using Confluent's data streaming platform for two main reasons. One is the online indexing to make sure that our AI recommendations and vector database searches are kept up to date. The other is the offline indexing, where we capture everything into our data lake to onboard new customers as they come along and want to start using our AI tools. The Confluent data streaming platform really is the backbone of our Gen AI use cases. In particular, it really allows us to stream changes as they get made inside the application itself directly into our vector database to make sure that all of our search and content generation capabilities are kept very much up to date. People using these systems expect to see their changes reflected very quickly. Confluent has impacted our Gen AI use case by providing a reliable, scalable backbone for all of our data transfer. It has ensured that our users always get real-time data when they're interacting with our AI tools. Using Confluent for Gen AI allows us to have scalability, real-time data availability without breaking the bank. And it allows our Gen AI applications to remain scalable and responsive. We have the ability to select between dozens of these different models. Notion's adoption of Confluent freed us from having to manage our infrastructure, which meant that our engineers were able to focus on building things rather than managing things.
We're continuing to iterate really fast. We build and enable new use cases like what's powered by AI today to help our product teams move fast. As an infra platform team, understand the right primitives, but then make them as accessible and as easy for them to adopt.
Leveraging Confluent has allowed us to scale our data streaming applications and make many of our AI and general streaming dreams a reality. And it has been noticed by many of the other engineering teams within Notion. They've started coming to us as they've seen other teams have great results with this and say, hey, how can we build something ourselves which is going to react to real-time events?
So yeah, myself Akash Agarwal, and I'm working for Swiggy as an architect for data intelligence platform team. Swiggy is a delivery app, so we kind of take care of quick commerce for food, groceries and rest of the items. Coming to Swiggy, there are three different customers, actually three different parties are involved here. One is the actual customer who make the order. The second is the restaurant partner where we give the order, and the third is the delivery partner. And all these three aspects required, a lot of real-time data to be available to them. Before using Confluent clusters, we were having our own open source Kafka. And then while open source Kafka works fine, but at the same time, need a specific team to maintain it. We had to invest a lot of bandwidth there to manage the infrastructure. And it was becoming very, very difficult for us to manage. And hence we decided to use Confluent offering. Now, instead of concentrating on the Confluent, we could actually concentrate much on the business side. And then, we were able to put good governance on top of it. We have two major use cases. The one use case is more of async communications between different services which we run like under the hood, right? And the second thing is It's more of we do a lot of business decisions on top of our data. So what happens is when a user open the Swiggy app or ordering food or groceries or any other things, then what happens is we give the predicted SLA, the time which we will need to deliver that order to the customer, and Confluent data platform help us to achieve that. Instead of concentrating too much on that specific tool, we could concentrate much on the governance, and that is how it helped us to reduce the cost. And in fact, we were able to reduce cost better than when we were having our own infrastructure. Confluent data platform is providing like the lineage and all that help us to figure out like how internal systems are connected to each other, and if there are any anti-patterns, we can figure it out, and it can help us to solve those complexities as well. With this Confluent data platform, right, where it gives Flink, managed Flink offering, and also DR and then connectors, that will allow me to concentrate only on the business side instead of, again, the different tools what we use and then we have to manage those tools. Today, our business is unpredictable, like how much can it go up and down. So that true elasticity will really help us to achieve our future roadmap. Confluent data streaming platform help us to enable real-time insights to all our 3 key pillars, which are customer, restaurant, and our delivery partners.
The mission of Booking.com is to make it easy for people to experience the world. And Confluent is making it easy for us to deploy data streaming. Hello, I'm Maxim Forsa. I'm leading the Application Data Services department at Booking.com. This is where we have all operational databases, data streaming services, and application services. Data streaming plays a very important role at Booking.com. Booking.com is using data streaming in multiple applications. The key reason we use data streaming is to minimize time to insight. It enables us to collect relevant data and analyze it and get the insight in minimal time. We use it in the context of security to understand fraud cases. We use it to power our experimentation platform to collect all events and decide what functionality we want to deploy for our customers. We use it also in the order context to understand all the changes that customers do on our platform. In general, data streaming allows us to be more efficient in software engineering. It allows us to have less custom code and do more efficient products and develop also faster for our customers. Data streaming is an important enabler for event-driven architecture. We are currently in a major transformation related to our infrastructure. We are looking to leverage a managed Flink for our real-time analytics cases, and we are looking to leverage the data governance functionality that we want to use to make our workflow more streamlined. We are happy to work with Confluent and use Confluent products. If it works for us, it can work for many more customers.
Set your SAP data in motion with Confluent Cloud. In today's fast-paced business world, your SAP data is more valuable than ever before. But is it locked away, isolated from every other system and application driving your organization forward? Meet Confluent Cloud, the cloud-native data streaming platform set to revolutionize your business with reinvented customer experiences, efficient back-end operations, and new business models and services. Apache Kafka, trusted by over 80% of the Fortune 100, has become the de facto standard open source technology for data streaming. But managing data infrastructure shouldn't be your focus. You need a data streaming solution that effortlessly unleashes the full value of your ERP data. Supported natively within SAP DataSphere, Confluent Cloud offers a cloud-native, fully managed, and complete data streaming platform spanning everywhere your business needs it. As an SAP-endorsed app, Confluent Cloud easily integrates your SAP data with any cloud or on-premises system in real time, bypassing the expenses and risks associated with self-managing open-source infrastructure. By connecting SAP DataSphere with Confluent Cloud, you unlock a world of real-time possibilities. From e-commerce to manufacturing, inventory management to sales analytics, the potential is limitless. With Confluent Cloud, you can build real-time applications at a fraction of the cost when compared to self-managed open-source data streaming. leverage over 120 pre-built connectors to easily stream SAP and third-party data anywhere it's needed, and harness the power of serverless Apache Flink for real-time stream processing. Hydrate SAP DataSphere with real-time data from Confluent Cloud. And rest assured, your data's security and governance are our top priorities. With enterprise-grade security controls and a fully managed governance suite, your SAP data is in safe hands. Connect SAP DataSphere with Confluent Cloud today and become the intelligent, real-time enterprise your customers expect. Get immediate, actionable insights from your ERP data and power modern, real-time applications everywhere they are run.
My name is Harikumar Venkatesan. We're leading a platform engineering team in Victoria's Secret. Victoria's Secret is all about a retail company. We are selling bras, lingeries, perfumes and accessories. Predominantly in Victoria's Secret, the data is a key for us, be it logistics, stores or digital systems that is coming into our plate. It's about how we can make real-time integration, pretty much the business use cases that we would like to cover, real-time data analytics, real-time monitoring and metrics, and also projecting our business decisions quickly rather than waiting on data or inconsistency in the data. When it comes to data architecture at Victoria's Secret, there are fragmented architecture, the data silos, those are all the complex issues that we're trying to deal with. When it comes to Confluent Cloud, it's resilient. I can click a few buttons to scale my architecture. The key benefit is multi-cloud replication and the multi-region replication and also the security. We have multiple data sources that is chiming into our system that gets data in and out. We have to make sure those are all encrypted. Confluent helped us to build a resilient system in such a way that I can put role-based access control in my data and also the SSL and TLS encryption so that I can access the secure data across all the systems in the enterprise. I can make sure my data is always consistent across the board. We can tap into the real-time data and build a metrics out of it so that the other team can actually feed in those data to provide financial metrics, customer metrics, and marketing preferences and personalized recommendations to the customers. There is no downtime for them. And because of that, it's the increase in terms of operational efficiency. We get to choose or shift our focus into multiple features that Confluent provides so that we can be better at other tools and technologies rather than investing our time and money in terms of architecture.
I lead a team that manages the operations, infrastructure, and engineering at Citizens, and my job is to make data available to my business partners and empower them to delivering incredible customer experiences. The expectations of the customers are through the roof right now, and the need to make data available in real time or near real time has never been greater, whether it is for fraud prevention, whether it's for risk management, whether it's for hyper-personalization, whether it's our digital channels and self-service channels. Making data available in real time is very, very important. And really the two pillars of doing that is APIs and streaming. We have been, over the past 3 years, in a journey to modernize our technology, infrastructure, and applications. We have a lot of legacy platforms on the mainframe, for example, and it's really, really important to unleash the data from these. We're doing that using change data capture, using Confluent. So I think we are one of the early adopters of Confluent Cloud Platform, and it's been really a key and important tool for us in unleashing data from the mainframe. When we came to the point where we had to stand up an enterprise-grade streaming data platform, we looked at multiple options, and Confluent was a clear winner, and it fit right into our overall ecosystem. The data footprint at any organization has increased exponentially. So how do you get data from point A to point B, and who are the consumers that need to receive that data at what time? How do you ensure the data is secure? How do you ensure it's accurate? So this is a very, very complex problem to solve. I think Confluent and what they do with streaming data, make it really easy for us to exchange data between applications. This in turn enables the business to come up with actionable insights in real time or near real time. And the demand for this has never been greater. What is the future of streaming data at Citizens? I think it's going to explode. So where would we be without data streaming platform? I think we will be out of business. Customers expect real-time experiences, and if we don't deliver it to them, they're going to go somewhere else. For us to be in business, stream data processing and real-time analytics on data in motion and actionable insights is going to be really very, very foundational to our existence.